right, guys, today we are going to be continuing to talk about the properties of trig functions on the unit circle. And we're going to take what we learned yesterday and kind of run with it. So we're going to be just taking it one step further. So remember from yesterday that when we looked at the coordinate plane, we focused on which trig functions were positive where. So in the first quadrant, we remember that all of them are positive. Second quadrant, sine was positive. Third quadrant, tangent was positive. Fourth quadrant, cosine. So this is a all. This stands for positive sine. This stands for positive tangent. And this stands for positive cosine. And remember the little acronym that we use to remember that? In order of the quadrants is all students take calculus. So this stands for quadrant 1. This stands for quadrant 2. Quadrant 3, and quadrant 4. And you'll remember that the reciprocals are also positive or negative. They follow the characteristics of their reciprocal trig function. So today we're actually going to be evaluating trig functions given the properties that we know. So zooming in on first example, you'll notice that we're asked to find all 6 trig values of the angle or the triangle that's given. So we're finding sine, cosine, tangent, and all the reciprocal buddies. Now, we're not given an angle like we were last week, like find the sine of 7 pi over 6. Instead, we're given information about the triangle. So first things first, we have to figure out where does the triangle sit, in which quadrant. So take a look at the information that's given. They first tell us that tangent is equal to 1/2. We will use that ratio in the future, but I want you to get out of that tangent is positive first. They have also told us that sine is less than 0. If sine is less than 0, that means we have a negative sign. So off to the side, do the work that you did yesterday. Try to figure out which quadrant this is going to land in. First of all, positive tangent. Tangent is positive in the first and the third quadrant, so we can kick out S and C. Second of all, sine is negative. Sine is negative in the third quadrant. It is not negative in the first. So we know that this triangle that they're referencing is in the third quadrant. So in the first step of these problems, you have to do the work that you did yesterday and determine which quadrant theta lies in. So we're now going to draw a triangle in the third quadrant in order to get us started finding all the trig functions. Remember that the triangle is always formed with the x-axis. The reference angle is always the angle that is snug close to the x-axis in the origin. And now we know some additional information about that triangle. We know that the tangent is equal to 1/2. Remind yourself what the tangent compares. The tangent compares the opposite side of the triangle to the adjacent side of the triangle. We are going to take that 1 and that 2 and actually stick it on our triangle. Opposite is referring to opposite of a reference angle. So our opposite is 1 and our adjacent is 2. Before we continue, check your signs. If you go left on the x-axis, this should be a -2. And if you go down on the y-axis, this should be a -1. Well, we're obviously missing the hypotenuse now. To find the hypotenuse, what should we use? Pythagorean Theorem. So find the third side of that triangle by doing the Pythagorean Theorem. -1 squared plus -2 squared equals c squared. Remember when you square a negative, it turns into a positive. 1 plus 4 equals c squared. So we have 5 equals c squared, so c is the square root of 5. 5 is a prime number. It doesn't have any perfect squares that fit into it, so we know that is the square root of 5. Your hypotenuse is always positive. If you need to, go back to your triangle, label your opposite, your adjacent, and your hypotenuse. Now we have a complete triangle, and we can find all 6 trig functions. Sine, cosine, tangent, and then we'll find the reciprocal buddies as well. Sine is opposite of our hypotenuse, so you get -1 over square root of 5. Rationalize. We get negative square root of 5 over 5. Cosine is the adjacent over the hypotenuse, rationalize. You should get negative 2 square root of 5 over 5. Tangent, they already told us, is 1/2. Now, take a second and also find the reciprocals. Cosecant is the hypotenuse over the opposite. You can simplify that to the negative square root of 5. Secant, hypotenuse over adjacent. Do not have to rationalize. And cotangent is 2 over 1, which is simply equal to 2. That is the style of the problem that we're going to be working on today. Zoom in and take a look at example number 2. We'll start out, just like we did in that last problem, by figuring out which quadrant we're going to sit in. So they give us that the cosecant of theta is equal to 4. By telling us that the cosecant of theta is equal to 4, they're giving us a trig ratio to put on the triangle, but they're also telling us that we have a positive cosecant. If we have a positive cosecant, we also know we have positive sine. They've told us that cotangent is less than 0. If cotangent is less than 0, then that means also tangent is less than 0. So we need to use these two pieces of information to figure out what quadrant we're sitting in. If we have positive sine, kick out the two quadrants where sine is negative. Furthermore, if we have negative tangent between these two that remain, where is the tangent negative? You should recognize that that is in the second quadrant. So now we're going to draw our triangle like our last problem, except now we have a triangle based on our properties that sits in the second quadrant. We have to fill in some sides of that triangle. Use the ratio that they have given you to fill in the sides of that triangle. Cosecant of theta equals 4. Well, we know trig ratios as two numbers, right? Something over something. This 4 we can situate over 1 since it's a whole number. Now you'll remember that cosecant is the reciprocal of sine, so this is the hypotenuse and this is the opposite. On your triangle, put the hypotenuse, put the opposite. Check your signs. If you go up on the x-axis, that should be a positive 1, and the hypotenuse is always positive. So this is our h, this is our o. Now we have to find the adjacent side. Just like in the problem before, to find the adjacent side, you should use the Pythagorean theorem. Take a second and fill in the Pythagorean theorem. In the Pythagorean theorem, you should get the square root of 15 as your remaining side. When you put this on the triangle, please make sure you're checking your sign. The answer that you get out of the Pythagorean theorem will always be positive. However, when you place it on your triangle, you have to think to yourself, when you're placing it on the leg, whether it should be negative or positive. Because it is going left on the x-axis in the second quadrant, this should be a negative square root of 15. Now, we can fill in all of our trig functions. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. Rationalize. Pause and rewatch if that stumped you. Now let's find the reciprocals. Cosecant, secant, cotangent. Cosecant is the hypotenuse over the opposite, 4. Secant is the hypotenuse over the adjacent. Rationalize. You should get negative 4 root 15 over 15. Not the prettiest answer I've ever seen in my life. And cotangent is the adjacent over the opposite, so it's just negative square root of 15. Hey guys, check your signs here. Notice, or remember, that all students take calculus. The only thing that should be positive in the second quadrant is sine. Well, would you look at that? Everything else besides sine and its reciprocal is negative. It's always a good idea to check your signs before turning in your work, before finishing the problem, and making sure that your work is complete. Let's try out the backside. Let's first take a second here and try to figure out what quadrant theta is going to be in. Tangent, they tell us, is -1, so we have a negative tangent. Sine, they tell us, is less than 0, so we have a negative sine. Using the first tidbit of information, negative tangent, we know it can't be in 1 or 3. Negative sine, between these two that remain, the sine is negative in the fourth quadrant. So go over to the right side, draw a triangle that sits in the fourth quadrant. Always form with the x-axis, not y-axis. Yuck. Y stands for yuck. X stands for excellent. That's where it should be formed. Just made that up off the top of my head. I know it takes talent. Okay, so let's check this out. Tangent, they tell us, is -1. Like we talked about in our last problem, we need two numbers. So with whole numbers, you can always stick it over 1. Tangent, fill in your ratio, is the opposite over the adjacent. So go to your reference angle, go opposite, we have -1. Adjacent, 1. You can do the Pythagorean theorem, but what kind of triangle has legs of 1 and 1, or 1 and -1? It's a 45, 45, 90 triangle. You should get your hypotenuse is square root of 2. If you did your Pythagorean theorem, you'd get the same answer. I would encourage you also in this step to label your sides. Opposite, adjacent, hypotenuse. Notice how even though our leg is negative, our hypotenuse is always positive. Fill in your trig functions, sine, cosine, tangent, sine rationalizes out to be -√2/2. Cosine rationalizes out to be positive square root of 2/2. Tangent, they already told us, is -1. Cosecant, you should get -√2. Secant, you should get positive √2. Cotangent, you should get -1. Hey, pause for a second. We're in the fourth quadrant. What's positive in the fourth quadrant? Cosine. Double check yourself. Oh my gosh, would you look? Everything that's not cosine is negative. Try the next one. Actually, I want you to try the next one on your own. I'll flash the answer key up in just a minute. Pause the screen and give it a shot. All right, folks, let's check this problem out. So first of all, you should have had that you had a negative cosine and negative sine based upon the information that was given. That should have landed you in the third quadrant. When you draw your triangle, you should have put the adjacent side is -12 up here. The hypotenuse is 13, based upon the ratio that's given to you, which is cosine. Use your Pythagorean theorem to find that the opposite side was, well, in the Pythagorean theorem, you got 5, but when you put that on the triangle, I highlighted this in green right here. Should have put it on as -5 because it's going down on the y-axis. Check out your trig ratios to the right. In the third quadrant, the only thing that should be positive is tangent. Notice how all these signs that are not tangents or cotangents are negative. Cool beans? Let's try out the next one. In this last one, they tell us that the cotangent is undefined. Cotangent will not be undefined on a triangle. Cotangent will only be undefined on an axis location. Kind of like tangent when we were talking yesterday. So let's think about our ordered pairs at each of our axis locations. If C, S, C, S. Alphabetical order or sign goes with Y. Cotangent is the reciprocal of tangent. Tangent is y over x. So cotangent is x over y, or cosine over sine. So let's see what cotangent equals at each of these values. Cosine over sine would give us 1 over 0, which is undefined. At this location, the cotangent, cosine divided by sine, would give us 0. Continue to go around. 180, cosine divided by sine would give us negative 1 over 0, which is undefined. And last, at 270, cosine divided by sine would give us 0 divided by negative 1, which is 0. So we've narrowed it down now to know that we can either be here or here if cotangent is undefined. The last tidbit of information they give us is that theta is in between pi over 2 and 3 pi over 2. So it's in between pi over 2 and 3 pi over 2. Well, which location is that? Zing! Over here at pi. So theta equals pi. Now we've got to find all 6 trig functions. Let's give that a shot. At that location, you should get that the sine is 0, cosine is negative 1, based upon our ordered pair. Tangent is sine divided by cosine, so it's 0 divided by negative 1, which is 0. The reciprocal of 0 is undefined, so cosecant is going to be undefined. The reciprocal of negative 1 is negative 1 over 1, so it's negative 1. And cotangent, they already told us, is undefined. So if they tell you that tangent or cotangent is undefined, you're going to be on an axis. Try out your homework, log into office hours if you're confused by any of those problems.